Well, I am Nicoline, and I am the host of today's webinar on synthetic data. I have here with me Sarah, our director in our innovation team, and Cornelius, one of our AI specialists. And they will be the ones to take you through the topic of today. At the end of the session, we'll answer some of your questions, so you are all more than welcome to post them in the Q&A session during the webinar. Yeah. So now over to you, Sarah and Cornelius.
Thank you. Hi, everyone. Good morning, good afternoon, depending on where you are connecting to us from. We are so thrilled to be talking to you today about something truly game-changing for consumer insights, which is synthetic data or synthetic respondents. It's a topic generating a lot of buzz, and for a good reason, in our opinion. One of our clients has recently described synthetic data as Ipsos Big Bang secret, but really we don't want to keep it a secret. We want to share with all of you what there's to learn here and how you can benefit from this. We believe we will revolutionize product testing, even though there's other applications for synthetic data that you should also consider. To begin with, we will look at Ipsos' overall approach to artificial intelligence, then dive into the specifics of synthetic data, specifically applied for product testing. And here Cornelius will walk us through two cases to demonstrate the power of synthetic data for product testing specifically. As Colleen mentioned, the end of the session will be reserved to answer your questions, so please get them ready. Share them in the chat box as you go along, or you can also connect with Cornelius and I after today's session if you're still curious. So let's get started into this topic. I would like to get everyone on the same page in terms of what synthetic data really is. But simply, synthetic data has been generated from an AI model, which has been trained to mimic statistical properties and the patterns of real-world data. Synthetic respondents are not a copy of human respondents. They are unique creations. They are unique on their own. Let's take an example. If we were to use synthetic data to understand better members of an Amazon rainforest tribe, then the synthetic tribe members generated would have their own identity and their own role and contribution to that tribe, while they would share the same culture, the same rituals as their human counterparts. When we talk synthetic data is not one thing. It is a collection of tools and methods that can be applied for different purposes and should be specific to the cases or the objectives that we are to achieve. On this slide here, we can see some categories of synthetic data. On the left side, we have the quantitative data augmentation methodologies or approaches, which go from data boosting to imputation and fusion. And then on the right side, we have agents or persona bots. And on the far right, we have synthetic panels, also known as digital twins. I would like us to go into each of these categories to understand a bit more how they can be applied. Data boosting, the one on the far left, this is the methodology that we'll talk about the most today, specifically in the context of product testing, but can be applied beyond it. Data boosting means adding synthetic respondents to increase the sample size of an existing data set. Thus, it creates a more robust sample, a more representative sample. Data imputation. The goal here is for AI to fill in missing or incomplete data points in an existing data set. It could allow, for example, in the consumer research space to shorten the length of the interviews or even avoid very repetitive surveys, making the service more engaging to consumers and therefore increasing the quality of the data that's collected. An example here could be, for example, a survey where consumers need to evaluate different brands on 50 attributes. It's quite a long list, right? But imagine that respondents could evaluate the brands on 10 attributes only, and then AI models would help us fill in or sort of answer the remaining attributes as if they were being exposed to consumers beforehand. So it fills in the gaps in that data set. Data fusion is a method where it combines not one data set as the previous two, but it can combine multiple data sets with the purpose of creating richer insights by cross-combining those different sources. For example, think of combining data from your smartwatch to a grocery shopping history that you may have, even training apps or meal planning apps, and all of that to help customize recipes that you can make based on what you have in the fridge, and also create training programs that support your health and your desired level of physical activity. That is already possible. That's an example of data fusion. Then on the other side, so the blue box here, we have persona bots and agents. This is a customized digital assistant or bot that emulate the consumer segment or is designed or programmed to know a specific information or to perform a specific job. You probably have noticed sometimes when you use your bank system or even your bank app that there are virtual assistants in those bank apps that can talk, for example, about mortgage options, and they seem to understand your financial situation quite well. Well, this is only possible because those chatbots have been trained on and to represent various financial profiles, and based on that, they can cater their service and their communication to you based on which profile you sit in. On the far right, synthetic panels, this is also called full synthetic data or digital twins. And this is the boldest application of synthetic data among all of those. Here we're talking about replacing real world data completely, 100% artificially generated data sets. And while a lot of this can sound new and might be newer applications to consumer insights and research, a lot of these have been used elsewhere and already in application. For example, in synthetic panels, this has been used heavily by game developers where they test their new games with synthetic players or CPUs within that environment to simulate gameplay patterns and see if it is working as intended. And they do this to pressure test those games before releasing them to the public. In the context of consumer research and specifically in the innovation territory, this is also being applied. Data boosting is the topic of today, and we'll talk more about this in terms of product testing. But on the far right, these examples that we talked about are already being applied, and you should, and there's concrete applications for you to consider. So for example, in the area of agents, persona bots, clients that already do a lot of concept testing with Ipsos, they can consider concept learning agents. So these are agents that have been trained on past concepts tested for a specific brand, but also a whole Ipsos database, and helps us consolidate the learnings and leverage that vast data set to understand not only what makes concepts work, but also what did not work in the past to help propel the innovation and the success of it even further. When it comes to synthetic data panels, then these full synthetic digital twins are soon being used to test ideas and concepts much earlier in the innovation process, allowing you to do it more often, much faster and cheaper than ever before. And while the focus of today is product testing, we have also successfully applied synthetic data boosting, so this case on the far left, for other types of studies, for example, usage and attitudes tests, and also segmentation such as demand spaces. So the technology is here. We can also be creative in how we want to leverage these technologies to help us in the consumer insights world. And I'm sure you've noticed artificial intelligence is literally everywhere. It's impossible not to see it today, not to hear it, and even avoid conversations when AI is not a part of that conversation. We believe that synthetic data and AI will fundamentally transform how we do consumer insights, how we innovate, and how we also do market research. And specifically, synthetic data will change how our capacity to understand consumers and use insights to the next level. However, not all AI we talk about and the models or the tools that we have available to us are ready to help us answer very big business questions. So public AI models such as Gemini or ChatGPT are now ready as is to help us in this world of consumer insights. They function as big black boxes that lead to outputs that are based on data that we cannot trace, that we cannot verify, imposing a massive risk when we want to develop insights to support decision making. These insights can often have significant gaps in knowledge, even hallucinations, or simply misrepresent the audiences or the consumers that we want to serve. It is very important then to remember that the outputs of AI generated are heavily dependent on the data or the sources that they have been trained on. So you probably heard this before, but we often say that garbage in, garbage out, right? So to succeed by utilizing AI and also understand what is at stake, I would like us to identify 3 big risks that you should be looking out for when having discussions involving AI tools. First of all, we want to represent the human experience and the consumers that we want to serve. So we don't want AI to be driving the show alone. To overcome this, we need to incorporate direct consumer feedback into the model instead of allowing the model to run wild. In the case of product testing, this means that we are using people's ratings on different products they have tried and use that data as input for the AI model to learn from, to be trained on. Then having a diverse and unbiased training data is also crucial. It's about representing the whole consumer group and not only a few of them. And this is important to avoid perpetuating or even amplifying existing societal biases that may exist in public AI tools. This avoids the risk of vanillification, as the picture here might reflect. And the vanillification of insights is the term that we use exactly to describe how public AI sometimes react to stimuli that we want to develop, because the data that has been trained on is largely skewed towards a certain Western white dominance, and that is reflected in the outputs as well. Finally, even the best AI models are intended to delight their users every now and then. And as a result, they can at times hallucinate or they make up facts when they don't have any. So traceability is incredibly important in general and is also very important to us. We need to be able to track our work back to specific sources. We need to understand how things work. And we do that by making sure that it's rooted in actual consumer data that we ourselves feed into these models. So to round it off and also to govern the use of AI within Ipsos, we have defined 3 principles to have into account every time we are creating a new model, every time we want to assess a model, being internal or external. And these are the ones you see here. So truth, transparency, and trust. A strong model, in our opinion, reflects all these 3 principles. It represents the truth, meaning we can accurately represent the relevant target audience that we want to understand. And to ensure accurate representation, we ground the models in real relevant data. So collect the data for the specific category, consumers, or market that we want to understand. The model should also rely on transparency. So that means that we understand how it works, how it produced that output, and what sources it used to inform that output. Was it the data we inputted, or was it something else? And then it must deliver an output that we can trust. And for us to trust it, we need to be able to trace it back to the sources. This preventing risks of AI hallucination, security, and fairness. It's crucial to remember that while synthetic data is very powerful, the product experience and the whole product testing experience is fundamentally human. AI has never lived the day like consumers have, AI does not have senses. AI does not react the same way we do. For instance, AI doesn't really understand that flavorful aroma of a freshly baked pizza out of the oven. AI doesn't understand the crispiness of the crust when you take a bite. And AI also doesn't understand all the emotions and the excitement you may feel when it's finally reaching Friday evening and you're going to spend some time with your family having that pizza. So for AI to understand all that complexity of human behavior beyond the ratings of consumers, we need to represent the human behavior and communicate it to AI in some way. We are also not logical or rational as consumers. So we need to educate AI to be able to behave similarly to consumers and understand the world as we see it. This is very important because all of this underlying context around consumers is not only defining what choices they make, but helps us provide context of why they make those choices. And these two elements are important for AI to take into account. This is why AI needs to be trained with relevant data and guidelines. We have to help AI, we have to structure the data somehow so that AI can understand beyond the technology and be able to capture those senses and that consumer experience. So when we train AI, we think of AI as raising a child to be smart. And when we raise a child to be smart, we offer them not only the facts, but also frameworks for them to think about problem solving when the facts may not be present or be relevant, to help them figure out a solution on their own. This also requires experience, right? So not only the student, but the teachers are very important by offering the AI students a chance to learn and try again. We allow AI to or the model to develop until we are able to prove that it does the job that we wanted the model to do. Similarly, we raise AI not only to provide the good answers, just like a smart child that reads all the books, but to be a critical thinker and avoid pitfalls as a mature child will then do. By training AI models with consumer-specific survey data, we then capture the essence of what drives real human behavior. In the case of product testing, which is the focus of today, synthetic data is generated from product test surveys that have been answered by real humans, real consumers. The AI model learns from the survey data, so it takes into account the respondents' demographics, their preferences, and most importantly, the ratings they have given to each product. And as said, we believe that the product experience or consumers' experience are human, they are unique to who we are. So synthetic data is not seen from our perspective as something that will replace human feedback or that should not be used for that purpose, but rather a tool to enhance the consumer feedback, allowing us to gain insights beyond what human data allows us to do and achieve even deeper understanding with still great confidence. More specific about product testing, synthetic data has other advantages besides just deeper insights. Traditional product testing is a resource-intensive undertaking, and here on the slide, there's a few examples of where time and money is spent along the way. Developing prototypes, securing manufacturing patterns, coordinating complex logistics, shipping, handling, recruiting participants, etc., etc., etc. These are all steps that take time, money, and meticulous coordination. And in today's fast-paced market, delays can mean missed opportunities or reduced competitive advantage in getting to market. Thus, synthetic data offers a way to reduce the spend and speed along the way. Synthetic data doesn't just improve product testing. We believe that it actually turbocharges it. It is one of the most expensive types of research given the face-to-face implications that it has. So it can benefit massively from synthetic data. Product tests that have used synthetic data here with us have benefited largely from three things primarily. One of them is increased agility, like we talked about, allowing us to bring products to market much faster, giving you a crucial edge against competitors, especially in this chase for growth, right? Then it can significantly drive cost cuts in both testing and production of the different samples for testing. This often translates to 20% and sometimes even 60% of budget savings. And the idea here isn't to save money just for the sake of saving money, but it's about maximizing the return on investment of every research step and freeing up budget for more critical initiatives. Last but not least, it allows us to get deeper insights. Synthetic data, as it boosts the sample size, we can unlock reads on subgroups that would have not been possible otherwise. Sometimes even hard to find groups, for example, in health-related surveys that are really niche. This actually gives us an opportunity to be able to have a proper read on those groups, something that was very difficult, time-consuming, and even investment heavy in this particular case. So overall here, the goal is to be able to do more with less. And our synthetic data approach allows us for more comprehensive testing, more frequently, and at the lower cost, helping you stay competitive, which is the most important part at the end of the day. For you to get even closer into the works of synthetic data, Cornelius will talk through two validation cases for product testing and help you understand a bit more of how this all works in the end.
Yeah, so at Ipsos, we truly firmly believe that synthetic data will revolutionize product testing. And then this in turn will also transform how we gather insights and how we make critical business decisions. And we don't believe that it's a temporary trend that's just here for a moment, but it's actually something that is a fundamental shift in our approach to understanding consumers and also in our approach to driving innovation. And so at Ipsos, we're not just using synthetic data, where we here are really pioneering its application in market research. And so, as Sarah mentioned before, synthetic data itself is not just simply copies of the real data. Think of it like lab-grown diamonds versus natural diamonds. Both are really valuable and serve the same purpose, but they are created differently. And our AI models analyze the unique relationships between data points in real human responses. They learn these underlying patterns and structures from these real human responses. Then they use this knowledge to create new synthetic respondents, each with the full data set, and that reflects the complexity of our human behavior. And so at Ipsos, we are not only doing this alone. We have truly built an ecosystem to drive the success and to put together some of the latest science and technology. And so we are responsible also for really driving thought leadership in this area. And this is because we partner with so many really great institutions like Stanford University and MIT and others. And specifically, when we look at synthetic data, we are partnering with Stanford University right now to ensure that we have the best synthetic data there is out there. And also, we are now proudly ranked the most innovative market research company globally, and this is for the 6th year in a row. And so let's get a little bit nerdy for a second. And so I'm going to talk a little bit about what's actually happening in the machine room now. And so our process really leverages two AI models. First is the generator, and second is the discriminator. And so the generator here is what creates the synthetic data. So it's really imagining new possibilities based on the patterns that it has learned. And then the discriminator is really this discerning critic evaluating the realism of the generated data. And this is all within a feedback loop, pushes the model to improve and refining the synthetic data until it's really virtually indistinguishable from real human data. So imagine it's just one machine creating the data, sending it to the other machine, which checks it over. Then it sends it back to the one who creates it, and then it's just going back and forth until it's really high quality data. And so this is truly a dynamic process of creation and refinement, and that really ensures the highest quality of synthetic data for our clients. And so we ran some experiments, and while the process is fascinating from really a technical perspective, ultimately our goal is validating the output. And because of this, we need to provide our clients the results that accurately reflect real world outcomes. And this is to inform really confident decision making. And so to validate our approach, we conducted extensive research exploring the effectiveness of smaller sample sizes and incremental value of incorporating synthetic data. And so we just didn't want to create something interesting. We wanted to create something that was truly reliable. And so I will now go into talking about some of these experiments we ran. The first one is without synthetic data. Our question was, can smaller sample sizes accurately represent larger populations? We know this is possible already in market research to a degree because it's really a fundamental principle. But in this case, we truly wanted to push the boundaries and determine the minimum sample size needed. And that's while maintaining predictive validity. And we wanted to understand how small we could go while still capturing the essence of consumer behavior. And at Ipsos, we already have a very large and historical database because we are the world's largest product testing advisor. And so we really tapped into this database that we have. And so we curated samples from various projects spanning numerous markets, categories, and also really a lot of different demographics. And in each of these studies, we selected a representative sample of 50 people from the larger data set. And that was for the end goal being to understand if those 50 respondents were representative of the larger original sample. And so our initial finding was that a sample of 50 real consumers can deliver results comparable to much larger samples. We found really a strong correlation of 0.80 between small and large sample results, and suggesting that the smaller samples can be surprisingly predictive. So a textbook, you could say, would actually say that 0.8 is a strong correlation, though we wanted to dig further into this to know when it comes to making large decisions and financial implications, we know that we also need to be much stronger. And so here we found a caveat. The accuracy of small samples depends on the differences in ratings between products. So as the differences between products gets larger, we saw that the correlation actually gets stronger. And so while our R&D shows that smaller samples generally works, it has some limitations. We cannot know upfront how a product will really perform. So using small samples requires us to be cautious when validating very final prototypes. And in other cases, this is just in high-risk decisions that we have to make. And also small samples lack the statistical power to reliably detect smaller differences between products. And even more so, subgroup analysis becomes very challenging when you have a very small sample size. And this is because there is a limited representation within specific demographics when we're only starting with a base of 50 respondents overall. And so this led us to our next test and case. It's do these small samples with as low as 50 human respondents. When increased with synthetic respondents, do they actually mirror larger human groups? So to validate this, we selected, again, a representative subset of 50 respondents from each study to be used as what we call the AI seed sample. And so this AI seed sample is the same respondents that the AI is then trained on. This seed sample is then used to generate an additional 150 synthetic respondents, or 150 synths. And so we compare the results from the 50 human plus 150 synthetics to the total human sample of 200 that the original data set had. And so our goal here wasn't to compare the seed sample to the augmented sample, because that would really be comparing it to itself. It was to investigate whether the augmented sample could replicate the results of the original 200 sample, hopefully better than the seed sample alone. So if the experiment succeeds, that would give us confidence in the predictive validity of our approach, really. And so the main question we wanted to answer was, would we make the same business decision with the augmented sample compared to the full human sample? And so this validation process itself is really crucial for us. And our results were honestly very compelling. In multi-product tests, the augmented samples mirrored the product ratings of the full human sample. The full human sample is on top. And then on the second row, it's the human sample plus the augmentation with human synths. And what we found, it's noteworthy that there are some minor differences. For instance, product B and F flip from second to third position, depending on the research scenario where we're looking at. However, these results are still at a statistical parity to each other. Yet the top ranked product in this case, product E on the slide, it remained consistent between the all human sample and the augmented sample. However, where we actually see the ability to see more significant shifts that we saw were when we looked into subgroup analysis. And this is because of the larger base size, which is due to the addition of the synthetic sample. And so we don't necessarily see a change in rankings between the products, but something really interesting that happened between, say, buyers and non-buyers in this case is we see that there were some differences because of the significance due to the additional variation brought in by the synthetic data. And so this ability to amplify subgroups allows for sharper and more concrete decision making. And so across all of our cases that we explored, overall product opinion really remained the same and remained consistent. We observed a strong correlation of 0.92 between the all human and all human augmented studies. And that was regardless of differences in the data. And now to really summarize our efforts, we validated our synthetically augmented data in 4 key ways, each designed to test a different aspect in its performance and its accuracy. First and foremost, we looked at the bottom line. Really, would this lead to the same business decision and action standards? Because that's what we're all really care about. And the answer is yes, in 95% of cases. Second, we dug a little bit deeper and we compared the product rankings between the augmented data and the original sample. We checked if the significant differences in ratings were consistent. Third, we got a little bit more nerdy and we got into the nitty-gritty and we examined really things like data distribution and correlations, because we wanted to be sure that what we were seeing in our augmented samples truly reflected what we find in real-world data sets. And so our approach was truly comprehensive to ensure the reliability and accuracy of our method. And so really the best part of this is that now it's just not a theory. We've done all of the hard work and it's already applicable in real life to what you are doing today. And so we've successfully implemented this method across really diverse markets, categories, and research designs. And this is from home care to food products, from countries like Brazil all the way to Vietnam, in both blind and branded tests. And in all of those cases, it was quite consistent.
Thank you. There's a lot of learnings here, and I think it's super exciting. We are, though, getting to the end of today's session, but I wanted to recap what would be the 3 takeaways of today. So if you have to take 3 things with you, let them be this. Firstly, synthetic data works, and hopefully Cornelius was compelling enough to show you why we truly believe in this. It works because it delivers the same business conclusions. So even with synthetic data, you would be making the same decisions as compared to if you had done the full scope of only human samples. And this applies to same decisions in 95 of the cases. Then we have also seen that small samples and as low as 50 respondents per product can deliver similar results as the largest samples. But we recommend sometimes higher samples depending on the risk level that you have or even in the phase of the development that you're at. Synthetic data also enables us to sharpen insights, get specific understanding of consumer groups or smaller subgroups that we could not have before, or even audiences that are hard to find, while also promising a higher return on investment with budgets saved between 20 to 60%. To me, this is enough proof. And while the focus of today's session was product testing, AI is being used in so many other areas and it's expanding in many directions. For example, AI is being used to develop new product ideas, to write concepts, to even ideate and improve recipes or even pack design. So if you're curious about this or more, feel free to reach out to Cornelius and myself. And before we get to the questions, stay tuned for the next webinar, which will be about concept learning agents, so another AI application. This will take place in February. The date will be announced soon. So if you feel that you're moving, but you're not advancing in your concept development and really want to learn from your past concepts and leverage our learning and innovation, then this is probably a webinar you'd be interested in. And with this said, I believe now we have time for some questions.
Yes, thank you, Sarah and Cornelius. We do have some questions in the Q&A.
Great.
So, first one. Do you always recommend a sample size of just 50 real consumers?
So as we talked about, 50 is as low as we recommend going. However, depending on how early phase your product development is, we would recommend different. So for example, if you are in very, very early phase and you want to prioritize different prototypes, and your risk threshold is relatively low because you have so many options and you only want to sort of take the best or the second best forward, then 50 respondents per product is enough. But as you're approaching your decision or your development towards the later end, if you have, for example, a medium risk and you only have a few products, maybe 75, it's going to be more indicative. And if you are in a very, very late stage or even a very high risk decision, then we actually recommend that you only use human samples, so no synthetic in that case, when you get to the light phases.
Thank you. And the next one we have here, any thoughts on how AI can benefit in product testing that goes across multiple markets? Let's say I'm testing a new product in Germany and China. How does AI take into account the local cultural context?
Great question. So every modeling, so to speak, is country specific. So it's not, let's say that in the study we have Germany and China, right? So the model is not going to merge two countries. We have to do it per product, per market. And that we guarantee that the countries don't bias each other, and we are only using category market-specific insights for that particular model.
Thank you both. That was it for questions.
All right.
But of course, if you think of anything after this webinar, you are more than welcome to.
Absolutely.
Yeah. Thank you. Bye.
Thank you for staying with us. Have a great day.
Bye.